Hello guys, in this video I'm going to show you how to solve maximum subarray of size k. So given an array of positive numbers and a positive number k, find the maximum sum of any contiguous subarray of size k. So for example, for given input 215, 132 and k is 3, so our subarrays had 3 elements, right? So the most easy solutions might be to calculate the sum of all subarrays of size 3, right? So maybe we will first we will start from the 2, for example. Oops. Okay, we start from 2, right? So from 2 we calculate the sum of 3 numbers starting from 2, right? And set the value and then we go to 1. We also calculate sum of 3 numbers starting from 1, right? 5, 1 is the last number because after 1, if we go to 3, we cannot have a 3 numbers 3 contiguous number from 3, so there's total of 4 in this guy. So we need to calculate 4 sum, right? So the time complexity will be n. We go from start to, we iterate from start to n, right? So it's n, and at each number we calculate the sum of k number starting from I, from the current number. So for each number we need to times k. So the time complexity is O n times k, and yes, it's kind of like a very easy solution to come up with, but for these kind of problems that we need to find the sums or average of all subarrays, right? We can think of sliding window, so that we don't need to recalculate from scratch for each number. For example, for the first 3 numbers, right, we calculate this window, we call it a window, right? For the next window, which is 151, we don't need to recalculate, but we take the previous window, we eliminate 2 and add 1. So by doing so, we we decrease our time complexity to O of n. Right? So let's try to run through our example manually in that way. So what kind of information we need to store? Probably 2 pointer, right? For sliding windows, we keep track of the current window by 2 pointers. So initially 2 pointers will point to the first number, right? So for each number we will let's say we will store the current sum, right? The current sum. Current sum will be the sum of the current window, right? So current sum initially is 0, right? So we start our loop, or we start expanding a window by first move the one pointer to the right and keep the other pointer the same. So for the first number, right, we start from 2, so current sum is 2. So we continue to expand our window. The right pointer is now pointer 1, so current sum is 2 plus the new number is 1, is 3, right? Then we further expand our window to 5, so 3 plus 5 is 8, right? But now here we have the window of size k, right? So from the point our window reaches size k, we probably want to check if it is the max sum of subarray of size k. For now, yes, because here is the first window we have. So max sum is now 8, right? Okay. So from this point, we not only move the right pointer, but we need to move the left pointer in parallel, right? So that our windows is always size 3. So by moving let's move the left one first, right? We move the left pointer, then we move the right pointer. It means what? It means we eliminate 2 from our current sum and we add 1 to our current sum. Now it's 7, right? It's 7. Okay. It's okay. We again check the current sum, the sum of current window, which is 7, with the current max sum. So it's less than, so we don't want to update our max sum. Again, we move our window rightward. It means we eliminate L1 minus 1 we add 3, so it's 10 minus 1 is 9, right? Is 9 greater than the current maximum? Yes, we update it. And we do the last round. Okay, we eliminate 5 and we add 2 to our window, so is 6, right? 6 less than the maximum, so we don't want to update it. So we've done, because our right pointer is at the end of the array, we couldn't move it forward, so we're done with iterating, with sliding a window to the right, so the maximum now is 9, so we return 9. So this is very similar with the problem average sum subarray of size k, right? So you can see the patterns, right? So whenever it's required to calculate all the subarray of size k, calculate either sum or average or whatever, then think of sliding window, right? To reduce your calculations. So let's go it down. Cause we need to store our current sum, right? Current sum is 0 initially. We need our current max, right? Let's initialize with minus infinity. So it's always, for the first time, is less than anything else, right? We need our window start, right? We need 2 pointers, window start and window end. Window start is 0, so we will use a for loop, right, to expand our window, right? Expand our window till the size k, then move our window rightward, right? Window end is start at 0, right? Window end is less than array length, of course. Window end plus plus. So for each iterations, we want to add the rightmost number to our current sum. Okay. Expand the window to the right, right? Current sum plus plus array at index window end, right? So so when a window is of size k, we probably want to calculate the max, right? So when the window is of size k, it means window n is at k minus 1, right? So if k greater than window n greater than or equal to k minus 1, it means, oh, our window is of size k. I want to update our sum, right? If it is greater than current sum, current max will be the maximum of current max and the current sum, right? here we have a window of size k, right? So in the next iterations, because we're in a loop, right? We're expanding the end of the window. So in the start of the next loop, the right will still expand. So now we at this point we also need to we need to move the left the start of the window rightward also, right? So now it's a size k, right? We move the left rightward, and the next at the beginning of next iterations we move the right pointer also rightward. So we always keep our window at size k, since window is equal to k minus 1, right? So by moving the window start, we need to eliminate it from our current sum, right? Which is the array at going to eliminate the window start, the number of window start from our current sum. And the next iteration here, wait a minute, we also need to update our window start, right? It's a pointer, because we eliminate the leftmost number is not enough. We need to also move the pointer rightward, move the left pointer rightward, window start, right? Minus minus, no, plus plus. So at the next iterations we again, so after this our window is upside k minus 1, and here we again expand the window n by 1. We add the next number to our current sum. So now our current sum is again at size k. Then we can, because from now the window n is greater than k minus 1, so we can have we can calculate another window of size k, right? So we'll do the same operations until window n is out range, right? So okay, so we exit the loop. So current max will store what we need, so we return current max. Okay, fine, it's work. So that's it for max sum Subarray of size k using sliding window technique. So thanks for watching, see you in the next video.